Yeah, we are go live now. Please start.
Okay. Hi guys. I am Yuan, and I am one of the Crust community volunteers. Welcome to the Crust workshop series supported by DoraHacks. Thanks to DoraHacks for your cooperation and support. Crust will have a workshop series for 2 months, and Crust will also design a storage activities for everyone in the later period. So please keep following us. And today we invited the Crust community developer Mingshi. He will introduce the ecological cooperation of Crust and some use cases. Hello, Mingshi. Hi.
Hello, Yuan. Thank you for the intro.
Yeah, please quickly introduce yourself and then start your presentation. So feel free to share your screen.
Yeah, I'm already sharing. Yeah. Hello, guys. My name is Mingshi, and I am a community developer from the Crust Network community. I'm leading a cross community development team called Sediment Tech, and we will work with the cross team to implement more features and deliver more products to the community members. Yeah, today I'm here to introduce Crust Network and its ecosystem and use cases. Let's get started. Yeah, I'm assuming that most of you did not know Crust Network very well, so I will start from the very basic about the Crust Network. So what is Crust Network? Crust Network is a decentralized storage project. Crust Network provides an IPFS incentive layer and a substrate-based blockchain that builds a decentralized storage network of the Web3 ecosystem. To simplify this, first, Crust Network is an incentive layer protocol built up on IPFS, and Crust Network is also a standalone blockchain. I'm assuming that some of you may be Web2 developers, so you may not be very familiar with IPFS. So I will start from IPFS first. IPFS stands for Interplanetary File System, which is a peer-to-peer protocol that enables users to store and share their data through distributed networks. However, IPFS itself is free for anyone to use. The problem about IPFS is that if you want to store your data on IPFS, it may become inaccessible after a period of time because the nodes are not incentivized and they can go offline anytime. Then your data will be inaccessible, which seems to be lost. Yeah. So Crust Network and some of the other decentralized storage network provides a solution. The solution is actually based on an economic incentive mechanism, which incentivizes the nodes, or we should call them miners in this situation, with tokens and to keep them online, and so that your data can be secured, it can be accessible all the time. Yeah. So compared with the centralized storage projects and compared with other decentralized storage projects, why does people choose Crust Network? What are the benefits and cool features of Crust Network? I will introduce them one by one. First is that Crust Network is very fast. It's faster than other decentralized storage projects. Crust Network's meaningful proof of work is implemented based on TEE, Trusted Execution Environment, which shortens the file sealing time and provides real-time on-chain confirmation. As some of you may know, that there is actually another incentive layer based on IPFS, which is called Filecoin, or we say FIL. Filecoin utilizes zero-knowledge proof, which consumes a lot of computing power. However, Crust is implemented based on TEE. It does not consume that much computing power, and it's much faster. To give a very specific example, if you want to store a 5 GB file on IPFS through Filecoin, the miners may take like hours to steal the file. However, on Crust network, it only takes seconds, and you can get real-time on-chain confirmation. You can see the difference is actually very huge. The second benefit about Crust network is that Crust network is cheaper than centralized storage solutions. Compared with some of the centralized storage solutions like AWS, Amazon Web Service, the cost of Crust network is over 1,000 times cheaper than the price for Web2 storage solutions like AWS. Also, Crust is with free API calls, free data transfer, and cross-region replications. Actually, I have a very specific comparison here. As you can see in the screen, here is a comparison between the Web2 storage solutions, centralized storage solutions, AWS, US East/1, North Virginia, a server located in North Virginia, US. The storage fee is 0.023 per gigabyte per month. And the API cost also takes fees. Data transfer takes fees. Cross-region replications takes fees. However, for Crust network, the cost is much cheaper. I don't want to read this number because, as you can see, it's way too long. It's over 1,000 times cheaper than centralized data storage solutions. Also, Crust network has free API calls, free data transfer, free cross-region replications, free CDN. Yeah. And let's get to the third benefit. The third benefit is that data stored on Crust network will have higher usability and data redundancy. Crust network currently has over 7,000 IPFS nodes and over 2,000 petabytes of storage capacity available. Files stored on Crust network have over 100 replicas distributed all over the world. What's the benefit of this? If you store a file on Crust network and one of the nodes go offline, don't worry, there won't be any problem too. There won't be your data won't be accessible because there are still over 100 nodes out there on the network that has replicas of your data. Yeah, and let's get to the fourth benefit. The fourth benefit is that Crust network provides powerful toolkits and very powerful community support. From a community developer's point of view, I think Crust team's technical ability is one of the best that I have ever met. They have implemented Crust files, Crust GitHub Actions, Crust pinning node package, IPFS Web3 auth gateway, and so on. I will get to it later in the workshop. Yeah. So let's move on. Today's topic is about Crust's ecosystem and use cases. I will start with Crust developer ecosystem. And the most important part of Crust developer ecosystem is the developer toolkit. It largely simplifies the process of using or developing on Crust network for developers and users. Crust, as I just mentioned, Crust implemented Crust files, Crust GitHub Actions, Crust pin node packages, IPFS Web3 auth gateways. I will introduce some of them. Yeah, the first one is Crust files. It is a lightweight and open source Web3 application that provides decentralized storage space for end storage users. As you can see in the graph below, basically it is a super user-friendly front end for users to place storage orders to store their files. You can choose to store your family photos, your movies, your videos, even your music on Crust network through this portal. It is very user-friendly for ordinary users. And more importantly, the cost of storing your personal all this data on Crust network is super cheap. So if you don't want to spend too much of your local disk space and you want to have a backup of your files and data, you can, even ordinary users can easily use this portal to store their files. And yeah, compared to other services like iCloud and even Baidu NetDisk, it is much more cheaper. Yeah, and Crust Network team has also implemented Crust GitHub Actions, which is for GitHub workflow users to publish their website or dApps by IPFS upload action. They can choose to ping or host their website by Crust ping action. As you can see in the graph to the left, here is a very specific example of using Crust GitHub Actions to ping your website, ping your dApps to Crust Network. It only takes, let's count, 6 lines of code. It's super easy. And if you are using GitHub repos to for your personal website, for your dApps, for your like all kinds of web applications, you can add this to your GitHub workflow, and all your latest all the latest version of your website will be pinged to IPFS. And Crust also implemented Crust ping node package. It allows Node.js users to store files with Crust. I guess this is more familiar with some of the Web2 developers. Like if you are running a social media platform and you want to have backups for your user data, like images on your social media platforms, you can easily use this Crust ping node package to ping them to IPFS through Crust Network. Yeah. One of the latest developments of Crust Network is IPFS Web3 Authentication Gateway. It is a lightweight Web3 based authentication service based on IPFS gateway and reverse proxy. Previously, if you want to keep your data pinged on IPFS, most of the users would choose some pinging service providers like Pinata, like Cloudflare, and so on. The problem about all these pinging services provider is that they are more centralized than you imagine because they run local IPFS nodes and all your contents are actually pinged to their local IPFS nodes. However, Crust Network implemented this IPFS Web3 auth pinging services, which allows you to ping your data directly to the nodes on Crust Network. So it's decentralized, it's distributed all over the world. Compared to the Pinata and Cloudflare, this is much more decentralized and much more safer to use. Yeah. And let's move to the next topic, the ecosystem of Crust Network. The ecosystem of Crust Network is growing at a very fast speed. Currently, there are over 13 projects in the Crust ecosystem. Some of them are famous projects like Uniswap, Liquidity's famous Ethereum projects, and some of the famous projects on Polkadot as well, like Conversation, Moonbeam, Asta. For Uniswap, Liquidity, and the Conversation, they choose to use Crust Network to host their front end so that their front ends will never go offline. And Crust Network is also working with some of the public blockchains like Polkadot, Solana, Polygon, Near, Aaron, Flow, Moonbeam, Asta, to provide IPFS integration and storage support. So developers and users on this and all these blockchains, all these public blockchains can easily store their files on Crust Network. Oh yeah, I will talk about it later. Crust has also collaborated with a lot of NFT projects. This NFT project, they either store their metadata on Crust Network or they just host their front end on Crust Network. Yeah. Let's jump to the next topic. The use cases of cross-network. Cross-network has 4 major use cases. The first one is DApp hosting. Developers can choose to host their front ends of their decentralized applications through IPFS and cross-network. I will talk about the benefits later. And the second major use case is NFT. Developers can choose to store their NFT metadata on cross-network to ensure data usability and decentralization. The third major use case is about file storage. People can choose to store all kinds of data, including videos, documents, images on cross-network for all kinds of applications. The fourth use case is cross-chain storage. Cross-network provides these storage solutions to users on different blockchains through X storage package and native IPFS integrations. Yeah, let's dive deeper. Why do people choose cross-network to host their dApps? What are the benefits of hosting dApps on cross-network? Yeah, the first one is about censorship. Hosting your dApps on cross-network or hosting your website on cross-network is censorship resistant. Imagine if you want to build an side hub. If you want to build a side hub or like Pornhub or other kind of sensitive website with sensitive content, or a website with some may have some controversial topics, you can choose to host your website on cross-network because you can really own your website. You cannot host all these kinds of things, all these kinds of websites, centralized web services, centralized storage providers like AWS, because due to some of the regulations, due to some of the customs, yeah, you just cannot do that. However, you can do all these things on cross-network because it's censorship resistant. Cross-network is also single point of failure resistant. What does single point of failure resistant means? If you are using centralized storage services like AWS, if one of their main server goes down, your website or your DApp will not be accessible anymore. However, for cross-network, if one of the nodes goes down, it doesn't matter because there are other nodes on cross-network hosting your websites or hosting your dApps. And cross-network is also faster compared to some of the centralized web services because you don't have to pay for CDN. Try to imagine if your website is hosted on a server located in the US, a cloud server, located in the US. If users in China want to access your websites, they have to go all through under the cables buried under the ocean. Yeah, and it really takes a lot of time. And the most widely used solution to this is CDN. However, cross-network itself provides CDN. So the accessing speed is fast for users all over the world because they will access the content on the node nearest to them. Yeah, and the fourth benefit is that it is cheaper. We have actually mentioned a lot before. I'll just skip. A very specific use case of DApp hosting on cross-network is Uniswap, one of the most influential and one of the decentralized exchanges with most volumes in the blockchain world. Uniswap has hosted their Uniswap V2's front ends on cross-network. As you can see, here is how the front end looks like. Here is the CID and the IPFS link. And everything you do on this front end is actually quite smoothly than you would expect. Yeah. Oh yeah, and something Martin mentioned that The deployment, the integration process is also very simple for Uniswap. They just add this the GitHub action here to their GitHub repo, and they achieve this. All the latest versions of their front end will be published, will be pinged to IPFS through Crust network. Yeah, let's move on. The second major use for Crust network is about NFT. You can store the NFT. If you are running an NFT minting platform, you can choose to store the metadata of your NFTs on Crust network. It brings decentralization because all the metadata of your NFTs will be actually stored in a distributed networks, and it also ensures the usability of the metadata of your NFTs so that people from all over the world can access it at any time. Yeah, the third benefit is about Sediment. We have actually mentioned that before. Here is a very specific use case of storing NFT metadata on Crust network. One of the community developer in the Crust community has implemented this platform, SwitchSwap. SwitchSwap is, to be more specific, an NFT minting platform. You can choose to mint NFT through SwitchSwap. You can simply upload the JPG image and it will be minted. And every minted NFT has this very unique identity card. This identity shows the CID of the metadata of your NFT on IPFS, and you can scan the QR code. You can easily access the metadata of your NFT. And SwitchSwap also provides something like gallery that displays your NFTs and NFT manager and something like NFT marketplace. Yeah, and their front end can also be hosted through Crust network. And the third major use case of Crust network is about file storage. This is a large use case. This is a wide use case. It can be used under a lot of scenarios. People have already implemented a lot of use cases and applications for file storage on Crust network. I will introduce one of them called Sockabay. As you can see here, this is the website of Sockabay. Sockabay, it is a decentralized version of YouTube. Basically, all these contents you saw on Sockabay, like dancing clown, funny animals, like even Crust tutorials, all these videos are stored on Crust network. And when you click them, you are actually accessing the files on Crust network on distributed networks. Yeah, you can search it on Google and you can access the website to try it out. The user experience is actually awesome, at least much better than you would expect it. It's smoothly, yeah. And other applications, including decentralized DocuSign, KiwiSign implemented by SkyKiwi team, and some functional integration, including Polkadot files. The last use case, or I should say, is the most potential use case of Crust network is about cross-chain storage. As we all know, decentralized storage is a fundamental infrastructure of Web3 ecosystem. A supplement to costly on-chain storage, decentralized storage can scale horizontally as a distributed network and can store unlimited data. However, as a fundamental of Web3 ecosystem, decentralized storage is designed to serve the entire Web3 ecosystem, including DApp staking, NFT metadata storage, GameFi, social media data storage, even hosting the metaverse in the future. So we want to use a single Web3 identity for dApps and personal data storage rather than multiple accounts. It is very similar to the SSO single sign-on in the Web2 world. There are many smart contract platforms right now, such as Ethereum, Polkadot, Near, Polygon, Solana. Each platform has its own dApp ecosystem. Web3 users use different identities to call smart contracts on each blockchain, and providing decentralized storage to users on different blockchains becomes a very basic requirement. That's what Crust Network is aiming to provide. Crust Network is trying to provide decentralized storage solutions for users on every blockchains. So there is a need for cross-chain. To achieve this goal, Crust has actually implemented through two ways. The first way is X storage palette. The second way is native IPFS integration for all smart contract platforms. Let's go deeper to this topic. X storage palette is an XMP-based substrate palette for all Polkadot parachains. I'm not sure if you are familiar with the structure of Polkadot. Polkadot is a public blockchain, but itself actually is only a relay chain, and there are many other blockchains connected to it through parachain slots. We call them parachains, yeah. And Crust Network will become one of the parachains, and the users on other parachains can send storage requests, messages, or with we call it extrinsics to Crust Network, and they can pay storage fees on Crust Network with native tokens on their project on their parachains by using the X token module. The code provided below is a very specific example of how the XAM transaction looks like. Yeah, so in the very near future, all the Polkadot parachains or the users on different Polkadot parachains will be able to use place storage orders on Crust Network to store their files, to pay storage fees through this very user-friendly and very easy operation. Let's move on. And another way is through native IPFS integrations. This is mainly for some of the major public blockchains with no cross-chain protocols like Polkadot. These public blockchains, including like Ethereum, Solana, Near, Polygon, Flow, and Avalanche. Yeah, so for users on all these blockchains, they can also place storage users on Crust Networks either through Web3 or IPFS gateway or Crust IPFS pinger. There are some public blockchains that has already integrated Crust Network as one of their decentralized storage solutions. These blockchains including Akala Network, Tawania Network, Polygon, Near, Hackle, Solana, and Moonbeam. Yeah, this is not up to date. That's the 4 major use cases of Crust Network: DApp staking, NFT, and file storage, and cross-chain storage. Let's conclude today's workshop. One of the GP in Multicoin once said they are excited about the possibility offered by decentralized storage protocols to reshape the core parts of the internet infrastructure. That is what Crust network is currently doing. The decentralized storage protocols like Crust network has the possibility to reshape the core parts of the internet infrastructure. In a very near future, we can expect a lot of decentralized applications to host their front ends through Crust network to achieve the true decentralization, and a lot of NFT projects to host to store their metadata, and even some of the Web2 platforms like Web2 social media just back up to their data through Crust network. And that's all for today's workshop. If you have any questions, you can visit Crust Network's official website or join our Discord and Telegram group. Our developer support is mainly at Discord. So if you have any questions regarding using or development using Crust Network, you can feel free to post your questions on Discord. Yeah, that's all for today. Hello, Yuan. Are you still there?
Yes. Hi. Hi. Thank you, Mingshi. Thank you for your sharing. Thank you for your time. If the audience wants to know more about Crust, please follow Crust official Twitter, Crust Network. And if you also want to be one of the Crust volunteer, you can search for the Crust Ambassador Program on Twitter. And contact information for business cooperation can be found on the Crust official website. And so at last, thank you all, Mingshi and DoraHacks. And please continue to pay attention to the workshop series of DoraHacks and Crust. Thank you.
Yeah.
Bye-bye.